All right, welcome to week 8, the last week. Congratulations. So our goals are to first understand the formal graph notation and learn what complete graphs are, identify graphs that have Euler paths and Euler circuits. So this G stands for the graph is equal to a set. The V is a set of vertices, this E is a set of edges, and the gamma are the set of paths that connect vertices and edges. So it tells us we have vertices A, B, C, D, E. So I'm going to make those, and you can do them in any arrangement that you'd like. So A, B, C, D, E. And then the edges are labeled E1, E2, E3, E4, and E5. And the gamma tells you the path for each one. So gamma of E1 connects A and B. So E1 connects A and B. The path for E2 connects A and D. So A and D is E2. E3 connects B and E. And then E4 connects C and E. And finally E5 connects E with E, so it's a little loop. So there's kind of a formal way to define graphs. Again, it's a set of vertices, a set of edges, and then a list of paths that go with it. A complete graph denoted Kn, so n meaning the number of vertices, so K5 would have 5 vertices. So there's my 5 vertices. And a complete graph means it's complete because it has all possible edges. So it connects every vertex with every other vertex. So I want to know how many edges does K5 have and what's the degree of each vertex. So I'm going to start just drawing out all the edges. So I'm going to start with vertex 1. I'm going to connect it to all other possible ones. So from vertex 1, I drew 4 edges. Then I'm going to go to vertex 2. I don't have to draw 1 to 1 because it's already there. I can draw 1 to 3, 4, and 5. Actually, I'm going to change those colors. So 3, 4, and 5. And so I had 3 from vertex 2. And then from vertex 3, I can go to 4, and I can go to 5. So I have 2 edges from there. And the only one left is 4 to 5. And so there's only 1 edge there. So notice the pattern is 4 plus 3 plus 2 plus 1, so that's 10. So that how many edges does K5 have? K5 has 10 edges. And in the degree of each vertex, so if you just look at each vertex and how many edges are coming out, you can see that there are 4. So 1, 2, 3, 4 coming out of here. And then 2 has 1, 2, 3, 4. And they all have 4. So the degree of each vertex is 4. So then in the homework you're asked to make some generalizations. So if you have K5, how many edges would that have? So think about the relationship between 4 and K5. And then also think about the pattern we got to find the number of edges that K5 has and try to generalize that for Kn. An Eulerian path or an Euler path, either one, is a path if you can start at one vertex. So if I could start at B and follow every edge and without retracing steps. So can I go around this figure? There's a path, but I can't repeat, so I never covered the edge AC. So there's an easy way to determine whether or not an Euler path exists, and that is by looking at the degree of the vertices. So vertex B has 3 vertices. This one has 3, 3, 3. And this is no Eulerian path. And we can tell because there are more than 2 vertices of odd degree. So not an Euler path because more than 2 vertices of odd degree. So you actually need, in order to have an Euler path, you need exactly 2. So let's do the next one. This has a 2 here. 1, 2, 3. This is 4. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. So this has exactly 2 vertices of odd degree. So this one should have an Euler path. And if you're trying to find the path, you should start at one of the odd vertices and end at the other. So I'm going to start here and just kind of go around. And I got back to the other one. So I started on the left 3 and I got back to the right 3 and covered all the edges without repeating any of them. So has Euler path. And again, the reason is because it has exactly 2 vertices of odd degree. In this last one, last picture, we have a 2 on top. 1, 2, 3, 4. 1, 2, 3, 4. 2, 4, and 4. So this actually has an Euler path, but we can be more specific. This has an Euler circuit, because there are no odd degree vertices. So an Euler circuit means that you start and end in the same spot. So if I start at F, let me try going around. And I got back to where I started from. So the first one had no Euler path or Euler circuit because it has more than 2 vertices of odd degree. The second graph has an Euler path because it has exactly 2 vertices of odd degree. And then the last one, graph 3, has 0 vertices of odd degree, which means it has an Euler circuit.